Hello, ladies and gents. Here's another presentation on homogeneous and inhomogeneous accretion and differentiation. As I hope this helps. If you need any more clarification, feel free to ask. But this is where I was really going, and this is a very important concept that I want people to understand. It's another Occam's razor. It's another simplification of the process of planet formation, streamlining planet formation in ways that make sense. In establishment astronomy, what they do is they have a bunch of protoplanets clumping together, absent a gravitational field, absent heat, absent, pressure. It all clumps together. So this is how they do things, okay? That's not the point. They just clumps all together, and then it ends up being a homogeneous ball. And this is the Earth as is. Homogeneous means same. Homo means same. So there's no differentiation. It's just a completely solid thing or liquid thing that doesn't have any differentiation. There's no core, there's no mantle, there's no crust. It's all the same. And over time, then they have the objects or the object differentiating. So the heavier material starts sinking after it's accreted together. So you have homogeneous accretion, and then you have differentiation. So you have the material clumping together, and then it differentiates itself into what we see today as a differentiated object, the Earth with its core, inner core, outer core, mantle, outer mantle, crust. Unfortunately, that uses two specific processes, and they're separated from each other. The accretion portion and then the differentiation portion. So you have step 1 and you have step 2. To streamline this, stellar metamorphosis uses inhomogeneous accretion. Now imagine a very, very big atmosphere around this object, but as it turns out, it layers like a pearl. You have a very tiny protoplanet in the center, or some object that's entered the star, and over time it starts layering onto that central object and forming layers and layers and more layers. So inhomogeneous accretion means there isn't the same throughout when it first starts. It's more or less you become differentiated as you form, which makes a lot more sense. It's just like what nature does. Think about the rings to a tree. Does a tree grow homogeneously and then form its rings, as or does it grow to its full size and then form the rings? Or does it start out as a small little sapling and then form the rings as it gets older and older, and it layers material onto that? That's up to the reader. And with this, there's only one real steady process, and that's one hell of an Occam's razor. I want, Baz to know about that, Charles, you too. And the rule of thumb is, if the star contracts, its inner core will expand due to extra material being deposited. So you have a large, hot, young star, and it's very nascent core, and then the star starts shrinking and layering material onto the core, and the core will get bigger and bigger, but very slowly as it ages. And the bigger the star, the smaller the core relative to how much mass was lost to begin with. So as the material is layered onto the central regions, obviously mass is lost via solar winds, solar flares, and that kind of stuff. And photoevaporation from hotter, younger hosts. Eventually those atmospheres get ripped away and dissipate away, and are subject to atmospheric escape when it hits a specific level of gravitation, to where the hydrogen can just, see you later guys. But it'll do that and then leave the little hard rocky ball in the center. But inside there, it's the inhomogeneous accretion, which occurs alongside differentiation. So differentiation process itself is literally the accretion phase of planet formation. It's not. The differentiation process happens after the accretion phase, which means that no matter what kind of rocky object you're looking at, this is Earth, you know, with its layers. No matter what rocky object you're looking at, guaranteed it was at one point a much larger gaseous object. And if you're looking at gaseous objects, guaranteed it was probably once very energetic and hot and big like the sun, because stellar birth is very violent, and the kind of energies required to pull all that material together exceed what is allowable via gravitational collapse alone. So it's electromagnetic phenomenon. Oops, EM phenomenon that bursts stars. Not the accretion. This is incorrect. But I'll go over that for another talk. Baz, I hope this helps. Hopefully I can clarify a little more for you. Today is June 13th, 2016.